Welcome back. In our last few classes, we have checked the divisibility of a given number by 10, 5, 2, 4, 8, these numbers, and we have learned the condition of divisibility. In today's class, we will be learning the condition of divisibility by 3, 9 and 6. So let's start the class with 3 first. So if suppose we have a 2-digit number AB, then we have already have the idea that how it can be represented in expanded form. It can be represented as 10 multiplied by A and then plus B, right? So 10A, it can be further expressed as 9A plus A. 9A plus A is 10A and then plus B. So further it can be written as 9A plus A plus B. Now 9A means 9 is a number which is divisible by 3. 9 is a multiple of 3. That means 9A, whatever is the value of A is, 9A will always be divisible by 3. That means if A plus B, the summation of both the digits of that 2-digit number, if that is divisible by 3, then the whole number will be divisible by 3. And that is the condition. That is the criteria. Let's check this criteria with some real examples. Suppose we have 63, this number. So 63, how it can be expressed? It will be 10 multiplied by 6 and then plus 3. That means 9 multiplied by 6, then plus 6 and then plus 3. So it will be 9 multiplied by 6 and then plus 6 plus 3, which is 9. So here we have 9 multiplied by 6. Since 9 is already multiple of 3, so 9 multiplied by 6 will be a multiple of 3. Now here 6 plus 3. 6 plus 3 means 9. So if that is divisible by 3, then the whole number 63 will be divisible by 3. Let's check. 63, if we divide by 3, then 3 2s are 6, then 3 1s are 3. So we have the quotient 21 and we have no remainder. That means 63 is divisible by 3 and 6 plus 3, 9 is also divisible by 3. So if we take another example, say 54. So 54, now 54 for this, 5 plus 4, it is 9 and 9 is divisible by 3. Now let's evaluate 54 separately. So if we divide by 3, then it will be 3 and then 24. So 3 8s are 24. So here also we can see that 18 is the quotient and there is no remainder. That means 54 is divisible by 3. So this is the logic. Now if we take a 3-digit number, say ABC, then ABC can be represented as 100 multiplied by C plus 10 multiplied by B and then A. So it can be further expressed as, it is 100C, so it can be further expressed as 99C plus C, and this 10B can be further expressed as 9B plus B, and then we have A. Now if we separate this 99C and 9B, and then the remaining terms are C plus B plus A. From here 99C plus 9B, here the 9 is the common factor. So if we take 9 common, then within bracket we will have 11C and then plus B, and then in the second bracket we will have A plus B plus C. So here what we can see that in the first part of this summation, one of the factors is 9. So 9 when will be multiplied by some other number, that will be also divisible by 3 as the 9 is divisible by 3. So we don't have any issue with this part. If now the second part where we have A plus B plus C, if that is divisible by 3, then the whole number ABC will be divisible by 3. Let's check again this with some example. Let's have 1 2 3, this number. So 1 2 3 means here if we separately take the addition of these 3 digits, then it becomes 6. 6 is divisible by 3. So now let's perform the division of 1 2 3 separately. So it will be 3 4s are 12, and then 3 1s are 3. So here the quotient is 41 and there is no remainder. That means 1 2 3 is divisible by 3, and by this logic also we have got 6, and we know that 6 is divisible by 3. So the same logic is applicable in case of 3-digit number also. Now if we take another example, say 701. Now 701, if we add 3 digits 7 0 and 1, it becomes 8. 8 is not divisible by 3. Now if we separately divide 701 by 3, then it will be 6, then 1 0, so it will be 3, then it will be 9, then 1 1, and then it will be 3 3s are 9. So here we will have remainder 2. So that means 701 is not divisible by 3, and from this logic also we have obtained 8, and which is not divisible by 3. So this logic is applicable for 3-digit number also. And even if we have higher digit number, whether it is 4-digit, 5-digit, or even more, the same logic will be applicable. If the summation of those individual digits in that number is divisible by 3, then the whole number will be divisible by 3, and that is the logic. Next we will see the divisibility by 9. Now suppose if we have again a number AB, so how it will be expressed? The same manner. So it will be 10 multiplied by B and then plus. So 10 multiplied B, again it can be written as 9B plus B, then plus A. So further it can be expressed as 9B plus A plus B, right? So here again we can see that 9B, that means we have one factor 9, another factor B. So it's obvious that 9B will be divisible by 9, and the quotient will be, or the result will be, B only. That means again we don't have any issue with the first part. If the second part, what we have, where we have the summation of both the digits, if that is divisible by 9, then the whole number AB will be divisible by 9, and this logic or this criteria is same as 3. So now let's check. Let's take one example, say 81. So 81, 8 plus 1, it will be 9. So 9 is divisible by 9, no issue. And if we divide 81 separately by 9, then it will be 9. The quotient will be 9 and there will be no remainder. So again we can see here that if the summation of both the digits is divisible by 9, then the whole number will be divisible by 9. Then if we take another example, say 47, and if we check the divisibility by 9, so 4 plus 7 is how much? 4 plus 7 is 11, and 47 if we divide by 9, then it will be 9 5s are 45, and the remainder will be 2. That means 47 is not divisible by 9, and that we have already seen from this result of addition of both the digits. Now if we take a 3-digit number, say A, B, C, and if we check the condition of divisibility by 9, then first we will express this A, B, C as C multiplied by 100, so 100, and then it will be 10 multiplied by B, and then it will be A. So further it can be expressed as, it is 100C, so it can be expressed as 99C plus C, and then 10B can be expressed as 9B plus B, that we have already seen in the last case, and then it will be A. So further if we take 99C and 9B, if we combine them, so the remaining terms will be C plus B plus A. Now from the first term we can see that 9 is the common factor here. So if we take 9 common, then within bracket it will be 11C plus B, and then in the second term we will have A plus B plus C. So what we can see here is that in the first part we have a 9 factor. So when we will divide by 9, we will have 0 remainder. So again we will have no issue with the first part, and if in the second part, if this summation of 3 digits A plus B plus C is divisible by 9, then the whole number will be divisible by 9. Now let's understand this with few examples. Let's take 4, 2, 3 as our example. Then 4 plus 2 plus 3 will give us 5 plus 4 is 9, and 9 is divisible by 9. Then As per the logic that we have learned just now, as per that logic, it should be 4 to 3 should be divisible by 9. And let's check that. So it will be 9 4s are 36. So it will be 6 3. It will be 9 7s are 63, and there is no remainder. That means 4 2 3 is divisible by 9. So this logic is also applicable for 3-digit number. Now let's check this logic with another number. Let's have 8, then 1, and then 3. So 8 1 3. Here 8 plus 1 plus 3 will be 12. 12 is not divisible by 9. That means 8 1 3 must not be divisible by 9. Now let's evaluate this separately. So it will be 9 9s are 81, and we will have 3 here. So it will be 0. That means we have a non-zero remainder. That means 813 is not divisible by 9. So this logic is also applicable for 3-digit number. Now even if we take higher digit numbers, say 4-digit, 5-digit, or even more, the same logic will be applicable. If the summation of all the digits in that number is divisible by 9, then the whole number will be divisible by 9. Next we will check the divisibility by 6. Now this condition, the condition of divisibility by 6 is, if suppose a number, whether it is 2-digit number, 3-digit, or 4-digit, or even higher, if that number is divisible by 2 and 3 at the same time, then it will be divisible by 6. Now let's understand this with few examples. Say we have a number 36. So 36 means 36 is divisible by 2 because the last digit, the digit at units place, is 6, which is an even number. And by the logic that we have learned earlier, if the at the units place, if the number is even number, then that number is divisible, the whole number is divisible by 2. That means 36 is divisible by 2. And again, if we add these two digits, 3 plus 6, then it will give us 9, which is also divisible by 3. So this 36 is divisible by 2, and at the same time this is divisible by 3. And we know that 36, if we divide separately by 6, then it will be, the quotient will be 6, and there will be no remainder. That means 36 is also divisible by 6. So this logic is applicable here. Now let's take another example, say 69. Now 69, if we look at the digit at units place, then we have an odd number, 9. So that means this number is not divisible by 2. But if we add these two digits, then it becomes 6 plus 9 means 15. 15 is divisible by 3. So this number is divisible by 3, but at the same time this is not divisible by 2. Now let's check the divisibility by 6. 6, it will be 6 1s are 6, then we will have again 6 1s are 6, and there will be one remainder which is non-zero. That means 69 is not divisible by 6. So here, when we check the divisibility, we saw that this is 69 is divisible by 3, but this is not divisible by 2. And at the same time, we have seen here that 69 is not divisible by 6. That means the logic that we have learned just now is applicable. Now if we take a 3-digit number, say 756. Now 756, this is a 3-digit number, and at units place we have 6, which is even. And since this is even 6, so this 756, the whole number will be divisible by 2. Now let's check the divisibility by 3. So 7 plus 5 plus 6, how much? It will be 6 plus 5, 11. 11 plus 7, 18. And 18 is divisible by 3 because the remainder will be 0 and quotient will be 6. So at the same time, 756 is divisible by 2 and divisible by 3. Now let's evaluate the divisibility of 756 by 6 separately. So it will be 6 1s are 6, it will be 15, so 6 2s are 12, and then we will have 36. So 6 6 are 36. That means quotient is 1 to 6, whatever, but the remainder is 0. That means 756 is divisible by 6. So here for 3-digit number also the same logic is applicable. If the number is divisible by 2 and 3, then that number will be divisible by 6 as well. And even if we take the higher digit number 4, 5, or even more, the same logic will be applicable. So in this class, we have learned the divisibility of a given number by 9, 3, and 6. In the next class, we will be learning the logic of divisibility by some other number. With this, I end today's class. Thank you.